Welcome to BEARDCAST, the mini-series within AI PHYSEC Today, the first and only podcast dedicated to uncovering how AI is transforming the physical security industry. I'm your host, Don Marone, and today we're unwrapping a holiday special packed with cutting-edge AI insights you won't want to miss. In September, I passed through the 7 levels of the candy cane forest, through the sea of swirly twirly gumdrops, and then I walked through the Lincoln Tunnel to arrive at none other than, no, it wasn't New York, but San Francisco, California. Over 2 action-packed days, I took detailed notes with my AI transcription app and sifted through the technical jargon, since it was an engineering conference, to distill it all in a must-hear 2-part series. In today's part 1 episode, we'll break down topics like AI agents, RAG or retrieval augmented generation, synthetic data, and small efficient AI models, all simplified and laser focused for the physical security industry. But before we get started, here's a quick highlight reel from my trip to set the stage. Let's dive in. Welcome back to BEARDCAST. Again, today I'm bringing you insights from the AI conference in San Francisco. We're going to be breaking down the AI trends shaping the future and how they're transforming physical security in ways that feel straight out of sci-fi. Let's get started. So on day 1, here is the TLDR. Day 1 was packed with game-changing topics like open source AI models, which are customizable AI systems for smarter tools. Then we've got knowledge graphs, which is basically like an AI cheat sheet that explains and connects data. Then on to on-device AI, which is basically AI that fits in your pocket, so no Wi-Fi needed. And then on to AI engineers, so AI that builds and improves on itself. So today we'll be focusing on how these breakthroughs boost physical security and keep us safer. So now on to open source AI intelligence, which is Meta's approach. So Meta is leading the charge with 30 open source AI models, and their biggest model has 405 billion parameters, which is a massive computer power achievement. And I must add, like, this is open source, right? So the idea is they're giving what's called a frontier model, kind of like OpenAI's ChatGPT or Anthropic's Claude, that are both closed source models. They're giving the model, basically the algorithm, to the public through mediums like Hugging Face, for example, where you can just download the language model or the foundation model, onto GPUs and be able to run their own inferences, right? And customize and fine tune it in ways that an API call won't allow people to. So ultimate level of customization. So kudos to Meta. Then some key takeaways were they discussed guardrails, which are rules that prevent AI errors, like mistaking shadows for intruders, like in our case. Hallucinations, which is basically kind of this topic around how guardrails could help, have been a problem, and they'll likely continue to be a problem because these systems do predict. But I believe that as these systems become agentic, which basically is the next topic, it'll be able to help itself validate through its decision making and hopefully reduces hallucinations over time. So on to agentic apps. So these are AI tools that don't just monitor, they act like locking doors and during a breach, right? And so we've got some companies in our space that have built these things, so kudos to them. But I will say that there's 3 main characteristics of agents that you should know about as a listener. So if you see them and hear about them, look for these 3 key characteristics. The first one is memory. Second one is chain of thought reasoning. And then the last, and probably most important, is actions. So with memory, it has context, so it's making the best decisions within the situation, right? The other one is chain of thought reasoning. So when it makes decisions, or as it's doing its reasoning capabilities, it's breaking down the problem in chunks, just like we do as people. And so therefore its logic and reasoning is less flawed than just simply predicting the next token like it had been in the past. And then last is actions, right? So these could be API calls that are attached to these agents that create actions. And in our case, maybe there's nuisance alarms that show up that aren't that important, right? And so the agents could certainly attend to those, and then you could have, the security operators attend to the bigger issues. We call it human in the loop within the AI space. But yeah, super exciting to see the future of agentic apps. Maybe you'll be able to order and book your vacations just by talking to your phone in the future. So on to physical security inferences for open source models. So custom AI solutions or custom AI tools, which is open source, are tailored AI for specific tasks. In our case, that could identify faces and detection within motion, right? But it's not just using deep learning anymore, or machine learning, which are prior forms of AI, if you will. It's using generative AI for the first time potentially inside of these applications. Now, I think they'll come in the first bit around, like in the form of chatbots or things that are where hallucinations aren't that big of a problem. But I think as these agents start to improve on the models to reduce hallucinations with the guardrails that I just mentioned before, I'm hopeful that Gen AI will make its way into these tools that we're using today. And again, guardrails, so filtering false alarms and improving reliability. Obviously, that's huge for us. And then we have agentic apps. So think of, again, AI security guards that respond instantly to threats. So why Microsoft thinks knowledge graphs are necessary for enterprise AI. Yeah, Microsoft knowledge graphs, they think they can get better AI answers. And I agree. So Microsoft is betting on knowledge graphs, which are webs of connected data, and GraphRag, which is the newest form, to my knowledge, of RAG, which makes AI smarter by adding context. And there was 3 key takeaways I took from this. One is that GraphRag, AI that uses maps of data to connect dots quickly. So we might go from RAG again to GraphRag, and then in the future made to something called agentic RAG. But the point is we're improving on retrieval augmented generation in order to map data and connect data, right? Then over to de-risk outputs. So this is where there's errors that are prevented by double checking AI responses. And then last is learning balance. So this is where AI is taught to combine skills with deeper learning. So now on to our physical security inferences, knowledge graphs. So graph connections, this is where AI links people, places, and events, helping investigations. Then we've got error prevention, which is minimizing false positives. And then last, balanced learning. This is where AI gets both smarter and more specialized for tasks. So now on to device AI, or AI in your pocket. So AI isn't just in the cloud. It's moving onto phones, into wearables, working offline with synthetic data for training. I said this, I don't even know, maybe 10 months ago. And at the time I was thinking there's no way these things are gonna live on the edge. Boy, was I wrong, right? So introducing small language models that enable that ability. Now, yes, it's still true for the larger models that are the hundreds and billions of parameters, but we're getting down to single millions or hundreds of thousands of parameter models that can live on the device. And I'm really excited for the future of what that means for the physical security industry. So some key highlights that I noticed: first is synthetic data. So this is basically fake data that helps AI learn without privacy risk. Again, key there is without privacy risk, or I would actually rather say mitigating privacy risks. Then we're off to this smaller AI models. This is the efficient AI that works in real time. Again, because I don't need to go to the web, everything's right there. And then micro parameters. So these are fine-tuned AI for specific tasks. And we can run these things like facial recognition on the edge, as opposed to going to a server or other things like that. So really exciting. On to our physical security inferences related to on-device AI. So much potential here. Obviously, we are in a business of Internet of Things, and for us to be able to put generative AI on the edge, to me, gets customers into some really powerful tech that can tell them all sorts of things. One example I found in the past is that, I think there was NVIDIA that had large vision models would be able to, I guess using their GPUs, would be able to tell an operator to say like, hey, I'm going to summarize everything that happened today within this video frame. And they have hundreds of cameras. And then take all of those cameras and summarize them and then call out the key points. This way they know where to prioritize and they can hold on to that history to really understand where events happened are more likely to happen the most. So just awesome all around and this opportunity for us to get on device. So first off is augmented training. So this is simulated break-ins to train AI models, right? So that's what we could do. This is a safe place where we can augment the training for these systems to improve and get better without actually doing these things in real life like you would have to do with machine learning or deep learning. Then on to privacy first data. So this keeps real information safe during the tests. And then last is portable AI. So AI on drones or cameras for real-time monitoring is a possibility here. AI and people, a new relationship. So AI isn't replacing people. It's augmenting them, acting like Iron Man's suit to boost productivity. Now, I don't think it's replacing people today. I think that there's certainly going to be an aspect where it will consume some jobs, but I think that it will enhance people's abilities and remove a lot of the mundane repetitive tasks we've never really liked to do in the first place. And so I do find that it's going to be fantastic for humankind. I'm certainly on the optimistic side of AI, but this was an interesting discussion, right? Where they talked about this topic, the relationship between AI and people. So some key insights that they discussed was 90% of employees use AI. So this makes AI tasks easier and faster. They're already familiar with it, right? So this is a great place to start. There's known creativity boost here. So AI takes care of routine tasks so people can focus on strategy. I love that, right? I mean, imagine that you go through the workday and all of the stuff you hate starts to go away and you can focus on the things that you love the most. And then last is testing solutions. So piloting AI in HR before full deployment, they were talking about is likely the best case. I mean, I would definitely recommend that. You wouldn't want to roll something out without testing or have a proof of concept first. But in any case, there's certainly plenty of companies that are going all in on this without having a lengthy proof of concept, really, because there's really nothing to prove if the data already shows that a creativity booster there, productivity booster there. It's just a matter of rolling it out in a way that makes sense for your company. So now on to physical security inferences. So for AI and people. So AI adoption, so most teams already use AI and speed up in their investigations, right? You're already using this. So you productize this in our industry, right? So you see them on our cameras, you see them in the access control systems for probabilistic machine learning, et cetera, et cetera, et cetera. But when generative AI comes in, there's opportunity to enhance so many more aspects of the system that we haven't looked at yet. And so really excited to see that, one, we've already been using it, and 90% of employees already use these AI productivity tools. So the moment we get it in our physical security systems, we'll just be like, hey, where were you all my life? Next up is creative uses. So AI tools like threat modeling free up security staff. Again, we want to enhance our abilities and live to our potential as people. And when we're stuck doing the mundane, we don't really get that opportunity to do that. So this is where this is going to help. And the last is HR testing. So start small with AI and managing ID badges before expanding. Start off small groups, leadership teams, but build a plan, right? You don't want to scare staff. Again, this is not replacing jobs, this is augmenting people. But certainly it's something that is the point, right? So the point is not to go out and say we're going to reduce staff by 20%. The point is first is how do we make our people better, and we kind of just let the chips fall where they may. Now on to IT networking for faster AI systems. AI needs fast networks up to 400 gigabytes per second. That's so fast to process data. And some of the key terms I took away from this that I thought were interesting were job completion time, JCT, which basically is how quickly AI tasks can get finished. And then next up was networking traversal time, or TCT, is how fast data moves. And then last was the leaf spine networks, which is basically better network layouts for AI. Now on our physical security inferences for networking. So first off, fast network or fast data transfer. This enables real-time AI responses. We're certainly familiar with bandwidth restrictions, especially with cloud products that we've had and used over the last decade. And so I think that inferences, especially with edge models, as we covered a little bit earlier, will reduce the need for consuming a ton of network. Mostly this segment was around data centers anyways. So got to give kudos to the people making the data centers, the amount of expense and time and everything in order to make these things work effectively is just super impressive. But ultimately, I think that's something we have to think about, right? If we're transferring information, data for the AI systems, how will that adjust? And something new to consider. Scaling up, so larger networks handle thousands of cameras and sensors. So really, we're scaling up compute more and more today than ever before. And so I think network connectivity and secure, not only just the connectivity, the security aspect of it, and then also the reliability of it are going to be really big as we move forward. And then last is better layouts. So simplifying AI setups in large buildings. So I think that when it comes to this networking piece, I don't know that on-prem it might change a lot. Maybe, right? I think we still probably use Cat 6. I think a lot of inferences will take place on the edge when we have small language models. That could certainly aggregate into an NVR, for example, or a server on site. But I find that the hardware will certainly keep up. I mean, even the industry, the AI industry, has agreed that compute is actually growing at a faster rate of improvement than artificial intelligence is, which is enabling artificial intelligence to grow at a highest rate of improvement it's ever seen before in the past. Now on to large language models, or LLMs, and large design models. So large design models, or LDMs, are advanced AI tools designed to simplify complex tasks like coding and design. But design is a big difference between what we've seen before. So one of the examples that I saw is that they took a Figma design and then ran a foundation model along with it so that it created the full front stack of that design. It was pretty incredible, to say the least. Now, some key insights that I had. So large design models, they turn designs into code instantly, saving time and reducing errors. They optimize layouts and adapt designs for different devices, making AI more versatile. And then last, tools like that I saw were plugins that I just mentioned before, allow teams to create responsive designs in seconds. It absolutely was incredible. Now onto physical security inferences for large design models. So automating designs, AI can create surveillance layouts and optimize security placement instantly. You can get faster deployment, so it saves times when adapting designs for new security systems. And then last, adaptability. So this adjusts for building layouts, lighting, and camera positioning. There's so much potential with the ability to leverage these auto designs. Really excited for the opportunity. Next up is evaluating AI agents. So evaluating AI agents ensures their decisions are accurate and reliable, or at least best ensures. And so some key concepts that I found were tools like, or tools that would monitor workflows and test AI performance. There was AI routers that decide what actions agents should take, like calling APIs or sending alerts. And then last were evaluations that include large language models tests, or language quality, and code tests, like execution accuracy, as they called it. Now on to physical security inferences for evaluating AI. So first there's routing accuracy. So AI will correctly prioritize tasks like identifying threats and over routine movements for us, right? Agent architectures, so these would allow, or could allow, AI to adapt and optimize responses based on patterns. And then last is testing methods. So this ensures that AI won't fail in a high stake situation. Again, I mentioned earlier, I think agents will be a mechanism to reduce a lot of the hallucinations that we're seeing right now. Certainly when you use one foundation model or one AI, right? It might be hundreds of AIs or agents that are working to give you the answer. So really exciting future for being able to evaluate AIs as we move forward. Next up is Advanced Retrieval Augmented Generation, or RAG panel. So these systems use AI to fetch and refine data for better answers. And some key points that I took were the following. Context precision. So this improves how AI retrieves information, which will reduce errors. Next up, I believe this is the newest form of RAG, which is agentic RAG. And these are AI tools that can break down questions and fetch answers in real time. And then last is challenges that include trust, privacy, and deciding whether to build or buy AI solutions, which is something I'll cover a little bit later. Next up is our physical security inferences for RAG. So better retrieval means that AI could more quickly pull relevant security footage and reports. Instruction optimization could mean that there could be improvement on how AI understands and responds to commands. And then last is real-time updates. This is where AI could integrate with live data for really update decisions. Next up is model alignment, like software engineering from IBM. So AI development is shifting to incremental, test-driven processes that are similar to software engineering. Some of the key insights that I took away was that data is structured in a hierarchy. So organizing it into trees or graphs for easier tuning is ideal. Then that next up was local training and quantized models, which are just what they're calling small models, make AI development faster and more efficient. And then last is testing, which is done by step by steps, really, that would overall improve the reliability before large-scale deployments happen. On to physical security inferences for model alignment. So smarter AI tuning. So this is where AI could be updated quickly to handle new threats. Hierarchical data models. This is where it would help AI understand relationships like linking suspects to areas. And then last is incremental testing, which ensures AI can adapt without compromising safely. Up is AI legal issues. So AI's growth raises legal questions about copyright, data privacy, and accountability. And some key issues that were discussed were that AI can create derivatives of existing works, which sparks debates over intellectual property rights. And then they talked about how developers must test AI outputs to avoid copyright violations. And then last was strong consent practices for critical. And last, they talked about strong consent practices being critical to keep user data secure. Now we have our physical security inferences for legal issues. So copyright protections ensures AI-generated reports respect privacy laws, secure data handling, which is AI models that must protect sensitive video and personal data. And then last, testing for compliance and AI systems that need audits to confirm legal compliance. And so my perspective here is that when the manufacturers make AI solutions using generative AI, right, that uses other people's data, basically, they're pre-trained on that. I think it'll be super important for them to have a really strong governance layer. And there's manufacturers like IBM that are providing DevOps enhancements around this topic, not just governance, but also data and just generally fine-tuning AI. The platform is called Watson X. And so I think as more manufacturers start to build generative AI into their services, they're going to want to deploy it safely so they're not on the other end of one of these lawsuits. Next up is AI engineers. So AI engineers is not the people we're talking about, it's the AI actually. So it's the AI engineers. Really, they're tools that are built to optimize other AI systems, automating improvements. So some of the key insights that I took away was that AI generates objectives, evaluates performance, and suggests fixes, or at least the AI engineer does. And then it also focuses on precision and creativity, leaving repetitive tasks to the machines. Some of the inferences I took for the physical security industry are that AI engineers could be faster, could deploy faster development. Obviously, AI engineers can quickly build and update surveillance tools. As far as improving precision, AI engineers could customize AI models for specific security tasks where we don't have the bandwidth to do that. And then last is cost savings, right? The more we have these tools do this work, the more we can, in some sense, democratize solutions that protect people, property, and profits, and everybody gets their enhanced AI features. So overall, reducing the reliance on manual programming, which I think is what cost savings will do. Next up is transforming customer success with AI. So AI is redefining customer success by streamlining support processes and automating workflows. And some key insights that I found were that 20%, that they were seeing 20% faster search results with AI that speeds up response times with pre-formed answers. And so 20% is huge, right? And then they went on to say 80% reduction in after call work for where AI would automate follow-ups and then free up staff time. And then there goes 10% boost for efficiency. AI would suggest responses in an asynchronous channel. So a key framework that was discussed was build versus buy, which I think was a huge takeaway for me, as a lot of companies look to enhance their business with AI. There's certainly an early stage conversation after they've discovered, okay, what are the problems we should look to solve? What are the repetitive, mundane tasks? Okay, great, I've got that list. Well, do I build or do I buy? And so there's a lot. This is a tough one right now because we live in a world where there's like a million AI companies and they're all making something awesome, and some of them are making something similar. But I feel that what you'll find with OpenAI is a great example is they've released some updates where the things that they did put other small startups out of business. And in my view, when you've got like the Microsofts and the IBMs and the Googles, of the world, for example, these kind of companies are going to be there to the end. They're always on top of the charts of Hugging Face for best models. And I just find that if I was buying as a customer, I would plant my roots in one of those big companies and try to hold off on any of these consumer grade tools if I can. And if I can't, that's fine. But I would leave it up. I would leave those tools up to maybe senior leadership, where you can better ensure that your data is not being misused in these consumer grade tools. And so, because when you buy commercial grade tools, you've got data protections and better guardrails and grounding and all kinds of good stuff that they incorporate in order to protect customer data. So when they went on to say build versus buy, they talked about organizations, they must decide whether to create a custom AI tool or to adopt off-the-shelf stuff, and that's it. Some physical security inferences that I took away for AI efficiency gains around customer service is that automated reports and AI logs incidents respond instantly. Preformed alerts, which is AI reduces operator workloads by generating response templates. And then, of course, the build versus buy options. So custom AI tools for sensitive sites versus pre-built systems for rapid deployments. So we've made it. Here is the list of the physical security inference summary that I took from day one of the AI conference San Francisco 2024. So looking ahead in 2025, it's all about AI agents. AI agents will dominate security operations, in my opinion. At least it will start that process. Some of the key trends that I've noticed was synthetic data was certainly a point of discussion. That AI training with synthetic data protects privacy and reduces bias. Next up, we've got efficient AI models, which are the smaller, faster AI tools that are ideal for edge devices without cloud dependency. And then last is this build versus buy decision where manufacturers build AI on top of frameworks, but productized AI solutions will drive market adoption. So I think that buying something that already exists is probably a good idea. You could build custom solutions if and when you need to, but certainly would talk to experts around that topic. So in closing, just wanted to take this opportunity to thank you guys for tuning into the BEARDCAST. Don't forget to subscribe for more AI updates and follow AI PHYSEC today for deep dives into AI and security. And until next time, peace.
Hey, drop.